Okay, so we have the assembly on the bench and we're going to proceed with the disassembly. So I'm going to start off with just removing these coaxial cables so we don't damage them. This is actually content 1, and we're going to replace the detector with a wider bandwidth one. This one operates to 12 gigahertz, and our signal interest is up to 16 gigahertz. Okay, and I'll move this one here too. Move from here. Trying to work around the camera. Start loosening these components here. They're kind of butted down, so you have to be a little bit careful not to completely unscrew that. It's actually not glued down, it's using double stick conductive tape. I'm going to start unscrewing the Hittite attenuator. The Hittite's going to be relocated to the front end. Remove this soap pad, the soft heat sink. I'm going to replace these 90-degree adapters with radius band adapters. They have better latching properties. These are not as good. Okay, so this is a barrel and a 3 dB pad. Okay. It's actually, I'm sorry, it's a 0 dB pad, the 3 is afterwards. To remove those So we do have an adapter plate. It's made by John back in Cambridge, and it goes just like that. So the Hittite will bolt down in that location, so I need to free up the wiring here. It's a good thing these harnesses are long enough for relocating the components, because otherwise you'd have to cut and splice. Okay, so RF1 is the input, so it's going to go like this now. And it gets bolted down, and we're going to use a male-to-male and a radius 90 here. So it's, oops, spring out. Okay, so I'm going to put this over here, and then it's going to get bolted down like that with the cover and the soap pad. Grab the male-to-male adapter. Looks okay. really snaggy. Okay. Next, these are ordered by Paul. Okay. So put it on loosely for the time being, and then we'll cinch it down once we get it to where it needs to go. This amplifier, I'm gonna have to maybe remove those to get the wiring on this to be a little bit cleaner. Connectors down later. Okay. So RF input, just make sure that it's oriented correctly. This part. Okay, here we go. Alright. Make sure it's clean. It is. And I'm just going to bolt it down here. Okay, so we're going to continue. I went ahead and put these 4 screws in to hold down this amplifier. They're 256 by 1/2 inch long, and we'll connect this next here. Later on, I might reroute that fiber. Actually, looks okay as it is, but a little bit in the way for right now. Okay, so we got that on, and we're going to add back this sill pad, they're more conductive. It's kind of conformable heat sink pad. So I'm not going to cinch it down quite yet. That looks okay here. So that's going to be the input, and let me just put a nose glue up there right now. There used to be a so this is the coax that goes to it, but I don't want to bend it so sharply, so we're going to put an adapter. Don't really spend. We're ready to cinch down now because there's it's in its permanent location now. Okay, so 8 inch-pounds. I've been doing this for a long time, so I don't use a torque wrench because they're kind of large. It's hard to get in these tiny areas. Okay, so next is to install this back, and we're going to run a coax. So basically the output of the amplifier has to loop around and go to the input of the directional coupler. This is a 10 dB coupler, and here's the, it's always facing away, but 4 to 20 gigahertz, and condet 1 comes out of that port right here. So this is slotted, so we can move it around a little bit and find the ideal location based on the coax. That's probably one of the challenging things, is to bend the coax to fit here. So let's just okay, so I went ahead and found some 256 by 1/2 screws and loosely attached that. So it's still, you can still see that it moves. A little bit of conformance here. And all I have left now are these 7-inch, there we go, 7-inch coaxial cable. They're flex, so easy to bend, 0.86 diameter. Okay, so basically I need to loop this here and then this side loop to the back side, so I'll do that right now. Okay, so I have a bending tool here. Okay, and then the other side, trying to make it symmetrical. Yay, I guess. Cinch down, and I'm going to fix this coupler position. Okay, so that's done. Let's cable a little bit here. I'll put the bolts in just to hold it down to what it needs to be for now. Okay. Sure. Okay, there we go. Okay, next we're going to add the slope equalizer directly to that connector. So XMA. 10 dB. Got these from Edward. Usually for things like this, I install the label face up so you could see. In the event that somebody wants to know what the slope equalization is, we have different values, but we make it face up so you can read the label. Okay, and then another coax from here to here. All I have again is 7 inches, so then another one to be like that. And we used to have this Hittite variable attenuator up front, and now there's no attenuator here, but there used to be a 0 dB and a 3 dB. We removed those, we don't use them anymore, and this 10 dB slope equalizer has about probably 6 dB nominal insertion loss, so that's why we remove the pads, otherwise there'd be more attenuation than we want. Okay, so again here, and you know, I also try to keep the labels up on this so we know what length coax. I haven't been consistent in using the same length. I've had 6-inch coax in the past, so the delay throughout this antenna IF assembly is not the same between unit to unit. But now that I only have 7-inch coaxes left, they'll all be the same from here on. So I'm gonna again bend this and then that. Okay, so here we go. If this were semi-rigid, it'd be a little bit more difficult, although 086 is fairly conformable. Okay, so I got this completely wrong here. So, let's see, how should I do this? Maybe I'll put this on first and then just. Okay, so that, and then being that this is soft, I could re-bend it. If it were semi-rigid, I think I'd have to trash this and start over because I bent it in the wrong way. Okay, I'm going to reform it here. Make sure there's no kinks. Okay, so let's get using this dial to make a nice radius band here. Okay. Okay, looks okay to me. Of course, we're going to sweep this entire assembly after completion, and if there is any problem with these coaxes, they'll show up. Make sure I cinch things down because I often forget in the end. Okay, looks good. Just one last check here. So a little bit loose here. Fortunately, this assembly doesn't see much vibration, with the exception of the ride up to mount a Kia. And then we install it into the antenna, and then it's doesn't see any vibration from that point. Okay, so we're going to remove this Krytar directional coupler again because it's not used anymore. We're going to reuse this blue mini circuits coaxial cable. So we got that off. Okay, so we're going to just unscrew it here. You know, we could just as well leave it in, except that it's better to have less number of components in cascade. Generally produces a better transfer function. Plus, we could reuse this Krytar someplace else in the system in the future. So these are rated from 4, I think it's 20 gigahertz here, 4 to 20, and so here normally would be the input, and then the 10 dB pickoff. It's not used in this case. And the main line, since it's a straight line going through, really does support from DC to 20 gigahertz, but it's the coupled port, the forward coupling, that's limited to 4 gigahertz at the low frequency end. And I did sweep it. It really is, the cutoff is at 4, and then down, if you go down to 3 gigahertz, the loss is quite large. So it's not 10 dB anymore, it's more like 20 dB at 3 gigahertz. So it doesn't work below that frequency, but the straight through path does work fine. So we're going to save all these couplers. We have quite a few left. Okay, so we're going to rebend this and see, kind of in an awkward position because of the camera here. See if I can rebend it in front of the camera. Pretty much done with this RF section here. And we're going to put a radius 90 on the output. So I'm going to put one of those. It used to be a right angle 90, right? And you can see here. So I'm going to replace it with this. Okay, so I'll leave it loose right now, and I'll take that off and discard it for right now. So you have a pretty large stash of these here. Okay, and this end too. So I'm going to keep the 3 dB pad here. So this is the output that goes to the fiber transmitter. I'm going to replace that one too. So it'll look like this when done. Oops, wrong side. Okay, so this end goes to the transmitter. This end goes to right there, but I'm going to put that on after I get it into the housing. Next thing is to change the continuum detectors. So we're going to start off using the same pads, but I found that more often than not we have to change the pads here. So we have a 10 plus an 8. Okay, so we're going to keep that value the same. And here's the detector, 10 megahertz to 12 gigahertz, and basically this is an SMB connector, and the new Critars are SMA, so I'm just going to have to discard this, not use it for now anyway. Okay, so we're going to replace it with a Critar detector. I have 2 of them here, and I have to go get some flax. So one does have to be a little bit careful in that these detectors are ESD sensitive. Unfortunately, I'm in Hilo, so the humidity is quite high. So this is what we're going to replace it with. 10 megahertz to 26.5 gigahertz. It's a Critar model 202A. So you do have to be especially careful up at Mauna Kea because lots of ESD up there. Okay, so that's that one here. And this is contact 1 here, so I'm going to replace that one first. And it has a 90-degree adapter here. And I'm going to keep this non-radius adapter because it's just a detector. It's not part of the main signal path. So I'm going to reuse this part here. We can't stand it up vertically because it's going to hit the top lid. That's actually not true. I think we could probably put it here, but we'd have to put the 90 here. We'll give it a shot, okay? It's a better interface if you just go straight down like this. If I have to add a pad between the quietar and the detector, well, they're both quietars, but then I'd have to put the 90 right at the quietar couplers, okay? Oh, I'm going to tighten that down. Let's stop a little bit closer. Okay, perfect. Here we go. Here's contact 1 and contact 2. So let's see if it fits like that. Okay, so I decided to reorder it. I know that the large value is going to stay the same. So kind of having to work around the camera here. So I'm going to put the and use this tool just to get the two pads apart. Okay, so this is the 10, and I know that from past experience that the 10 has to stay, and I'm going to select and test the smaller value. In this case it's 8, but it might need to be changed to a 7 or 9. So I'm going to raise it up a little bit. The 10 will stay there and it doesn't have to be changed. But this is the 8. And for the same reason I mentioned before, it's okay to use this right angle 90 here because it's not in the main path. The main path is straight through. This is just coupled to measure sampled power. And in fact, this detector is used to servo, software servo. So there's small millivolt level DC coming out of the detector. It gets amplified by a DC amplifier in here. It gets sent out and digitized. And that digitized value is compared to a preset target value. It's usually around 7 volts. and then attenuates the input signal accordingly. Can make the stop batteries die. Okay, so I went ahead and removed the screws for the level monitor board, and I'm ready to change the resistor value. So, see if I can see this. R3 is currently 12.4K, and you could barely see the 3 here on the component ID. I'm going to remove that and replace it with a 510 ohm resistor. So probably won't be able to video that, but I'll show you after. Okay, so here's R3 changed over to 510 ohms, and just kind of a view of the assembly looking down. So we ended up putting in the Hittite, male-to-male, radius bend, chow amp, coax to the input of the Krytar coupler, coax to the slope equalizer, MyTech amplifier, remove the other Krytar coupler, jumpered it with this blue coax, the output to the white coax to the fiber transmitter, which you could sort of see where the green fiber optic connectors coming out. So this is the optical output right here. And here's the RF input right there, okay? And power connector and telemetry here. And we did change the content 2 and content 1 right here. So we're ready to reassemble into the chassis and give it a test.